Okay, in this video, I'm going to talk you through the lab you have to do for U3A4. In this lab, what they're going to ask you to do is find the heat of MgO. And what they're going to do is give you 3 reactions, and each of these will have a heat, and you have to do a Hess's law to get this to add up. So the Hess's law itself is not that hard, but here's the trick. They only give you one of the heats. So you need to have these 2 heats. Well, what they do is they give you information for reactions 1 and 2. Oh, by the way, you might have to look this heat up. I'm not sure if they give it to you or not. But you would find out the heat of formation. So what you would look up if they don't give it to you is the heat of formation of H2O liquid. I believe that's a liquid there. So what you have to do is you have to do calorimeters to find the heats of these 2 things, put those heats in here, then rearrange these 3 reactions, cancel out to get this target, and then add your heats up. So let's talk about how you would get the heat of this reaction. Well, first of all, to get the heat, you need Q equals M times C times delta T. So they give you information on MgO and they give you information on Mg in a table. Well, we need a mass in here. Here's where people mess up. The mass you're going to use is the mass of the liquid in the cup because that's what's absorbing the energy. What is the liquid in the cup? It's HCl. Here's the thing with HCl. It's 99% water. So you're going to treat it like it has a density of water, which is 1 gram per mil. To find your mass, to use in this formula, what you're going to use is you're going to use the volume of HCl, and because it's 1 gram per mil, whatever number of milliliters you have that number of grams. Here's the next thing. You're going to need a C value. You might be tempted to look up the C value of HCl. Don't. Remember, this is 99% water. So you're going to use the 4.18. Then in the data chart, they give you the temperature change that occurs in the water. So put that through and get Q. Remember what I said in an earlier video, divide your answer by 1,000 to get it in kilojoules. So you might be asking yourself, why did they give me the mass for magnesium oxide if I don't use it in this formula? Well, you do. Because whatever answer you get in kilojoules, you have to divide by the moles of MgO used. So take the mass of MgO, which they'll have in that chart, and divide it by the molar mass of MgO. So if you go into your periodic table, I believe you're about 23.9 and about 15.9. So you're going to be around 40. Don't take my word for that. Look up the molar mass of Mg, look up the molar mass of O and put it in here. Take your mass, divide it by the molar mass, take your kilojoules, divide it by this number here, and this will be your heat that goes right up here. Use your calorimeter, which is just a styrofoam cup, to do the second reaction here. Put your heat in here. Rearrange the formulas, add all 3 up, okay? You're going to have to do a percent error in here. I did a video on that earlier. So what you're going to have to look up is your known value you should have got for the heat of MgO and see how close your calculations were.